graph to show and confirm our results. So we're considering the interval from -1 to 2 of the function 3x to the 4th minus 4x cubed. So this is the closed interval, and you can see that the highest point on the graph within this interval is this point, and the lowest point would be 1, -1. Now, notice that even if 0 is a critical number, it does not necessarily mean that it will produce a minimum or maximum. So in this case, 0, even if it's a critical number, did not produce a relative maximum or minimum. So some notes that you need to remember. Note that the critical number did not yield a relative minimum or maximum. So it tells you that the converse of the theorem is not true. Okay. To rephrase that and to reiterate that, it means the critical numbers of a function need not produce a relative maximum or minimum. Okay, this next example involves an absolute value function. And we said that an absolute value function does not exist at its peak. When talking about peak, it's where the function goes from decreasing to increasing or increasing to decreasing. So these are the peaks of the function. It is actually where the absolute value is equal to 0. So in this case, this absolute value, the derivative will equal 0 when the absolute value x plus 4 is equal to 0. And that is when x is equal to -4. So -4 is the only critical number of the function. So now we're going to evaluate the function at the critical number -4 and at the endpoints -7 and 1, or +1. So f of -4 is 0, f of -7 is 3, and f of 1 is 5, which gives us the absolute minimum is going to be 0, and the maximum would be 5. So we will be working on these problems in class tomorrow, but if you'd like to get a head start, you can complete some of them.